all. Okay, in this episode of my washing machine series, this is episode 12, WMS E12, washing machine series, episode 12. And I'm going to summarise on all the components before I finally put all this in the skip, because I'm going to be salvaged and keep a few parts that are useful. But before I do that, I'm just going to show you every single component that went into our old Beko washing machine. Now, if you look back on our my earlier series, you'll get all the episodes regarding my new washing machine and the old machine and all the various stages of disassembly regarding the old washing machine. So this episode, it's just going to be like a summary regarding this one, regarding this old washing machine. The series will continue on for other things that I want to show regarding washing machines and our new machine, and any other demonstrations, perhaps if we get the motor running or whatever. But this episode is just showing you all the parts. I'm going to group them all together in their components, and I'm also going to weigh them as well. So I've got a set of bathroom scales here. I'm going to weigh all the parts, and I'll give you the summary of the, what makes up the overall weight of the washing machine. It's around about 70 to 75 kilograms. Right, so I've tried to piece the components into a reasonable, as best as I can, ordinary fashion. Now, I've done a pump demo with this on the previous episode. It had been episode 11, sorry. So this obviously doesn't count, the flex for this. I could probably remove that. But everything else does. All the hoses do. So I've got everything laid out, and I've got the scales here as well to weigh the parts. I've even got digital scales to get the smaller parts as well, to get the overall weight for all the components. So I'm going to start with the bodywork. So first of all, I'll just move this pump over the road. So it's made out of pressed steel panels. Everything is completely out, it's been gutted. This is the front panel, it's all held together with fixture screws. Now I've got a bag of various fixture screws in these bags. I'll put all them in, all this stuff will go into bags, and I'll weigh them as a whole, like a bag assembly. So you've got the front panel, just very thin steel, pressed steel panel. Then you've got the plastic finishes, like the control board. Now the circuit board's been taken out. I went through all this on the earlier episodes regarding the push buttons. When you're pushing these buttons, it's basically just pushing against pegs, which will make contact with the switches on the circuit board. I went through that on the earlier episodes, so I'm just going to quickly summarise on this episode. So that's the front dress panel, that's the control panel that goes on the front there. Then you've got the lower panel, the lower valance panel, kick plate as it's sometimes called. That's so you could access the pump to drain it. There's this flap there, you get the filter and also the drain hose, which is the corresponding filter, and the drain hose. And that there goes on the bottom of the pressed steel bodywork. So you've got that. So moving on to the back, you've got the back panel, which basically is self-explanatory. This just comes off so you can change the belt. That's what covers that there. They've got the top panel, which is quite heavy actually. It's made of a composite, so it's not made of steel, it's made of like a plastic composite or something. It's maybe heavy as well, so that it doesn't resonate with the frequency, but it's quite heavy compared to the sheet steel body panels, press panels. And then you've got this here, which is a cross beam that comes off. That's just for the control board, fixtures to that as well. You've got the wire harness, which is just clipped on with various support clips. Well, that's actually the suspension one, but you get the idea, I hope. That's the mains flex for the plug. You plug it into the socket, goes into the big capacitor, and then into the rest of the circuitry via the wiring harness. That's connector blocks, spade connectors, earth leads, etc. They've got the motor and the heater element on the drum. These wires are for the solenoid at the back for the inlet water. Then you've got this insulation, like, well, it's actually just more a sound absorbing material. Then you've got the lower suspension struts for shock absorbers, basically. That supports the bottom of the drum. The drum's been cut in half. I've done that in an earlier episode. But the suspension springs are there at the top. That's a suspension drum. So that's really the bodywork. So there isn't really much more in the way of that. It's just pressed steel panels, spot welds. In some cases there's spot welds, and a series of fixing screws as well. Like the front panel came off with fixing screws. Moving on to the door. You've got the door hinge here, basically on the front panel. That's integrated with the front panel. And you've got the door assembly. I took apart on the previous episode. That's the glass, which is sandwiched in between these two door panel strips, if you like, circumference. So the handle, the door mechanism. They're held on with screws or with Torex, so if I remember right I had to go and do it in another video because I didn't have the tools at hand. The glass is sandwiched between the two bits there. And your door interlock, which is the locking mechanism basically, that's electrically operated. That prevents you from opening the door on the washing machine while it's in use. So moving on to the door seal now. It's a big rubber heavy duty door seal. That is what sandwiches between the outer casing of the drum, which is the white bit there, and the front panel. Basically it's the door seal, it's heavy, quite robust, flexible piece of rubber. These are held in with a series of spring. It's like a circumference, it goes around the circumference of the door seal. I think that was the top one, you have to put that around the door seal, and then there's the bottom one as well, which is, I think it was either that or the other way around, but that flexes. It's hard to demonstrate on the camera, but it does in fact. It's springy, and that's what springs around the door seal to keep it in place. Moving away from the door seal, I've got now the soap dispenser drawer. You just press down on that and the drawer comes out. Powder, softener, pre-wash powder. This is where the water will come in through these channels there, as I explained in an earlier video. It's fixed onto the chassis. That's the inlet, the inlet pipes for it. They go in the back. And the solenoid, the inlet valve for the water, is what's responsible for controlling the water going in and out. And I took apart the solenoid in a previous episode. I completely took it right down. There's a coil of wire in there that acts on the electromagnetic coil principle. There's one that I haven't completely broken, but as the solenoid moves, this thing screws. There's like a worm screw on there, and that basically causes the valve to open or close. It cuts off the water from the water coming in, and it will just impede the water, stops the water from coming out of this bit here, which eventually goes through these pipes to go into the soap dispenser drawer. So that's the valve inlet set up there, the solenoids. There's two of them, one's broke to bits to get into it. This is the heating for the element for the drum. That's a thermometer, so the machine knows how hot the water is in the inner drum. The element is there. That's the heating element for the outer drum. Moving on to the outer drum, you've got the two drums. You've got the inner drum, which you'll be familiar with, that's where the clothes go in, and you've got the outer drum, which is maybe not so familiar because it's inside the machine. You have to take the covers off to see it. That's the rear bearing. That's where the spindle in the back of the inner drum goes through. There's an inner and outer bearing base. I'll try and show you that. And they're really difficult to come out. They're waterproof, obviously, so the water doesn't come out. That's the heating element I was on about. This thing has been severed in half. So I could get. It's sealed for life, so I couldn't actually remove the inner drum without breaking it open. It's the back of the inner drum. These are just buffer stops, so when it's spinning and moving around, it doesn't hit off the panel. That's like that to siphon hoses and various hoses. That's your inlet hose from the soap dispenser that goes down into the inlet port, which is on this half. The water will then go down. It's either that or the other way around. I can't remember now. That's this one here. It's the top one. So the water will go down through this hole and eventually go into the inner drum, and that's the flexible hose for that. This is the inner drum. That's the spindle that goes through the bearing on the outer drum. That's the bearing there. It goes through it, And at the back of that you've got the drive spindle, the drive pulley rather, which screws on to the back of this. You get the drive belt, which connects up to the pulley on the motor. That's what this is responsible for driving the drum. So on the back of the drum you've got the spider, back of the inner drum rather, that's the drive spider. So the pulley, that there is driven by the motor. This drives, it's splined onto this spindle, the spindle rests on the bearings, and this spider, which is supported on the circumference, because as it's turning, it wants to turn on the circumference of the drum. If it turns there, it's going to twist, you know, it'll cause a lot of twisting in the metal, so they put the spider out to the far edges and it'll turn on the circumference of the inner drum. That's what it's mounted to it. Right, so moving on. At the top of the drum, the outer drum, you've got these weights. Well, there's actually one at the top and one on the front as well, which fits. It's secured on the front circumference. Basically it's to support the drum while it's moving. It gives it extra balance. And these, I've got the weights of them somewhere, I'll get them later on. They're made of concrete. I'll reweigh them and put them in this video as well. Pressure switch, that's for controlling the amount of water. That actually detects how much water's in the drum. It acts on the diaphragm, which I had a minute ago there. That basically is affected with the pressure in this hose, which is connected to the outer drum. So when the drum fills up, it pushes it, it basically creates pressure inside this hose, which acts on this diaphragm here, which basically sends the signal to this micro switch, closes it, and then it will send a signal to the main circuit board. This is the main circuit board here. This is what controls everything. That's the brain of the machine, this microprocessor. That's all your switches, your digital display, a lot of relays as well for high voltages, heat sink, thermal kettle, I think that is. Plastic shrouding that went round the circuit board when it was installed in the machine just to protect it. This is the, I think it's the triac for AC to DC or something. It's high voltage anyway. This is another part of the high voltage side of the circuit boards. This had a heat sink on it as well. This was all covered in my earlier episodes, by the way, so you could look back on them if you want. This was how it was mounted to the side of the washing machine, inside the casing, the bodywork rather. That's the inlet hose. What else? That's the springs, the suspension springs. That's what supports the drum. So basically these go through there, more or less, and it hangs up on the inside of the top edge, the inner edge of the casing. And they're just, as your self-explanatory, they're heavy duty springs. That just supports the weight of the drum. But it's full of water, full of laundry, it's quite a bit of weight. And the shock absorbers at the bottom, there's, because remember this is cut in half, there's two on that side there that are there, they're just gas filled. They're not, well, they're just wrapped on there, they're not actually sealed. It just draws in air and it works in conjunction with the struts at the bottom. So there's two on this side. And of course they move with the position of the drum as well. On to the drain pump. I've done a demonstration on this on the previous videos. I won't really go into much more on this. I've already covered it quite considerably. It's basically responsible for emptying the water out the drum. Comes in, it drops to this sump pipe, which is at the bottom of the outer drum. Water goes through here. It's then just basically displaced through this pipe. It's pumped up into your drains basically. Covered that on an earlier videos. What else? And you've got the main drive motor, AC universal motor. It's quite a sturdy unit. It's heavy, I will get the weight of it. Covered a bit of this on the earlier episodes. Just a wee recap. It's got windings, stator windings, and it's got brush windings, rotor windings. These green things have got the carbon brushes on the end that make contact with this ring here. Because that ring turns, the brushes rub against that. That's what supplies electricity to the rotor windings in there. Works on electromagnetic principle. The stator windings might just see one of them there. It's one of the stator windings. There's windings that go around there. They're wired up in phase. I think there's 3 phase or something, and it basically energises. In effect, it's electromagnetic. You put 2 magnets together, it repels. Well, it works on a similar principle. It magnetises, it becomes magnetic when you coil up these, power up these coils, and it basically repels. And it does it in a rotationary motion. That's how the motor works. And it's got a tachometer as well at the back here. There's a couple of wires. The tachometer is responsible for measuring the speed of the rotor arm, basically the speed of the motor. It sends the signal back up to the motherboard microprocessor, and it's then determining how fast the motor's going. So it knows whether or not to supply it with more energy or not, depending on the load that's on it. If it's loaded up more, and it's going to go slower unless it gets more power, the tachometer will read it going slower, so at the end it decides to give it more electricity, basically, to go faster. Put it in a nutshell. I'm not a technician. As I say, everything in these videos that I do are just for entertainment purposes only. Don't quote me on it. I'm just giving you my understanding of it. And now, while I do this video, just a very summarising, showing you the parts and just giving you my explanations. I'm not a washing machine repairman or an electrician or a mechanic. My dad's an electrician, he would be able to explain better, but it's me that's doing the video, so I'm just giving you my explanation. That's as I mentioned earlier, that's to do with the measuring the temperature of the water. Basically, the probe, that's the heating element, heats the water up, and this measures how hot the water is. So when it reaches the set temperature, signal sent to the motherboard, it then tells the heating element whether to go on or go off. So just a wee summary, and then I'll get the weights of all these components next. Quite a lot that goes into it when you take it apart. You will disregard the flex on this, because that isn't part of it. That was for an experiment, so ignore that. That's just held together by spade connectors. So I've got the series of scales. I'm going to weigh all the components next, and I'll get the whole summary of all the weights that make up the overall weight of a washing machine, of the Beko, our old Beko washing machine. So I'm going to do that next. I saw the model when you saw the front panel, and you could see the model. You could actually see this washing machine doing its final wash, by the way. That was on one of the earlier episodes of this washing machine series. I can't remember what one it was, but it's titled appropriately. So if you're interested in seeing it doing its final wash forever, then you could do that if you want. To get the weights, I'm going to, for these smaller fixtures and stuff, all this stuff here, I'll put them into bags, and I'll just call it like bag 1, bag 2. The bags will be negligible as far as the weight's concerned, and I'll just weigh the bag, and I'll put that down as a component, and then I'll weigh all the individual. This will be weighed on its own, the weights will be weighed on its own, the drum and that, I could do all that separately, but all the wee bits I'll just put them into one big bag. Then it will make up a significant weight that these bathroom scales will pick up on. Of course, the other way to do it is, if I stand on the scales, I get my own weight, which I know, and then I just carry the component. Then that gives me the gross weight. That's my weight plus the weight of me carrying the components, and then just simply deduct my weight from the gross weight to give me the component weight, and that would probably be an accurate way of doing that. But all you'll be getting to be told on this video is the weight of the components. I'm not going to tell you my weight. So that's my weight now, with me carrying nothing. So it comes in at 112 kilograms. So what I need to do now is carry something and get the overall weight, and then subtract 112 kilograms. How I'm going to do it is everything on this table, this pasting table, except for the weight 1, weight 2, the stabiliser weights. The motor, I could weigh them actually just by putting them on the bathroom scales, and they will register because they're heavy enough to register, therefore it'll be accurate enough. All of this, from there onwards, all this stuff here, all that is going to go into a black bin liner. The black bin liner will be nothing virtually, it'll be negligible, so not really overly interested. That, by the way, in case you're wondering, is out the solenoid. That's I think I mentioned that earlier. Look back in the earlier episode, you'll see me take it apart. So I'm going to put all this into a black bin liner, and I'll call that black bin liner component number 1, and then I'll get the weight of that. Then I'll weigh all the other bits individually. When it comes to doing this, I'll just carry that as well and do it individually. So in addition to this black bin liner, The pump flex, that's negligible. Okay, well, I'm not going to bother about that. I'm going to also put these plastic panels in as well, because it means it's just one way less that I need to do. It saves me time. Alright, so what I might do is carry them in one hand. So black bin liner plus bottom kick plate and top dress panel, the control panel. I'm going to carry that on my left hand, I'll carry that on my right, or vice versa. One hand will be carrying this, one other hand will be carrying A2, then I'll weigh myself, that'll give me the overall weight. And then just deduct 112 kilograms from that, then you get the weight of these components, which will then leave the weights, the supporting weights, as one screw. You'll never get it 100% accurate, because bear in mind, when you saw something or break something, you get dust. That's all part of the wash machine, so if you want to get it to the last gram, you know, you couldn't do it unless you captured every bit of dust, every granule of everything. You know, it's impossible for me to do that with the instruments that I've got. So I'm now giving you, like, I'll be pretty close, I'll be about 99%, you know, which is good enough for me for this video in this instance. So that's what's left to be weighed. So I'm going to do this and call this bag 1. So you know all the components that's gone in there, and you know what's absent, and you'll get that for the weight, the ingredients going into the wash machine. The problem is if the arse comes out this bag, right, because there's a lot of sharp stuff in it, that's going to be a problem. So I can't really zoom in at the moment. I'll try and do this before the arse bursts out of this bag. Right. So it's coming in at 121 kilos. So I'm carrying the 2 bits of plastic under my arm. Right, so it's about, you can see 112 is what I am with nothing. So I'm going to put that down as 121. So that's 9 kilograms, that's about 1.5 stone. Oh, just for my own records as well, I've put it down, wash machine components weight. So A, miscellaneous black bag 1, 9 kilograms. That consists of what you saw me putting in there earlier. The next task, I'm going to weigh each of these weights. No, I'll get the hardest bits done first. I'll get the chassis, the actual bodywork. So I'm going to have to lift that and weigh myself, because this is too big to put on the scale. So I'm going to have to carry it with get the gross weight, you know, just like what I did with the black bag. So carrying it, it's coming in at about 124. It's difficult to focus that in, but let's say that's 124 kilograms. So that's 12 kilograms for this. So the main bit, the washing machine, the bit you see most, is actually it's relatively light. It's big, but it's relatively light. It's hollow. In fact, one of these weights I think will be heavier. So just this bit here with the wiring harness in it as well, by the way, and the flex and the capacitor, and a bit of the insulation, which remains of the struts as well. Right. All this only weighs 12 kilograms, but it is hollow, it's thin steel, thin gauge steel, it's pressed steel, like car bodywork. It's shaped, cold pressed I reckon, and spot welded. That's all it is, but it's shaped in a way that makes it structurally strong. That's where the suspension by the way. Or was it there? No, that's the locking bit. No, sorry. The suspension, yeah, it's this, it goes on that, it rests on there, and I think there's something that goes over there that locks down on it as well. That's just for the wiring harness, by the way. This actually doubles up as 2 things. The wiring harness clips in there, the suspension spring goes there, and I think there's something, if I remember right, one of the plastic bits that will be in the miscellaneous bag went down there to lock the spring in place. So the next thing I'm going to do is weigh the, it's difficult now because I'm going to weigh the back panel and the top panel and that cross brace. We'll do these 3 next. Okay, I have to actually mark it in just of all the weight, I don't forget. Right, so I've logged that in. So that's B, bodywork without the back lid, without the top lid, back cover and front panel. See video, so that gives you more details, like, because it includes wiring harness, etc. So that's 12 kilograms. So I'm going to do the 3 panels here on its own, which is the back panel, top lid, and this cross panel. So it's coming in at about 116 kilograms, so it's I'm going to put that down as 4 kilograms for that. So that's 4 kilograms. That's that logged in. So top lid, back cover, control panel, cross mounting panel, stroke brace. 4 kilograms. Next, I'm going to do the front panel on its own. I'll just weigh that on its own. So, carrying that panel, it's coming in at about 115 kilograms. I'm going to say 3 kilograms for this panel. This front panel will weigh about 3 kilograms approximately. Right, so that's that done. And I've logged it in as well. Front panel D, front panel 3 kilograms. I could do the motor and the weight separately, but the big stuff won't fit on the scales, so I'm going to have to now do them the same method. So I'm going to carry the inner drum and I'm going to get the weight of this. So weighing it, carrying the inner drum, coming in at about, I'm going to say 118 kilograms. So that's about 6 kilograms for the inner drum. 6 kilograms for the inner drum. 6 kilos. So I've logged it in. E, inner drum, 6 kilograms. Next, I'll do the outer drum, and I shall do the back half with the heating element and the bearings. This is the bigger of the two halves. It's quite heavy, as you could probably hear me putting a certain effort into moving it. It's competent. It's also got the remains of the struts on there, a siphon pipe at the back, which is going to be part of the overall wash machine weight anyway, so it's just to get the actual how the wash machine actually tallies up to its weights. So I'm going to weigh this back half using the same method. Now this is quite heavy, you could feel that just by lifting it. And this is coming in at, I'm going to say 120 kilograms. 121, 120 and a half maybe. It's quite a tough one now. I'll put it down at 121 actually. So that's quite heavy. It's got the bearings in the back. It's the bigger of the halves. It's quite thick because of all the stresses. It's got to be structurally thicker. That's where the spindle goes through, supporting the bearing. So yeah, I'm going to put it down at, it's hard to tell, it fluctuates, but sorry, it's 121 kilograms, so that's 9 kilograms at least. It's quite thick here, the material's thicker, a lot more forces are exerting on it. Heating element still in it, bearings, some of the struts, and heating element all adds up. So that back portion of the outer drum comes in at 121, 9 kilograms. I logged it in. F, back portion of outer drum, including bearings and element, and there's a siphon pump pipe as well. But anyway, 9 kilograms for that. See video, which will show all the parts that were in it at the time of filming. So I'm going to move on to the front portion of the outer drum. This is considerably lighter. Plastic's thinner as well. So it's coming in at 114 kilograms. So I'm going to write it down as 2 kilograms for the weight of that. But it's considerably lighter. It comes in at 2 kilograms, but there's virtually nothing there. It's just thin plastic. And it's the thinnest part as well, because all the stresses in that are in the back part, where the spindle goes through. It's been logged in. So G, front portion of outer drum, 2 kilograms. Next, we'll do the weight, the front supporting weight, stabiliser weight. This I can put directly onto the scales. I've already weighed them, can't remember off the top of my head, but I'm going to weigh them again anyway. I'll do that for this one, top one, and I'll do the motor as well. So first one is the front one, front stabiliser weight. It would have been a very long time since I last weighed 2 stones. Anyway, the front stabiliser weight comes in at 2 stone exactly, which is 6.36 kilograms per stone. So I'll just, for this, so you can see it's sort of sitting between the 12 and the 13 kilograms. So I'm going to just mark it in as 13 kilograms. Look at it, 13 kilograms. That's the weight of the front stabiliser weight, concrete block. So this one weighs, front concrete weight, 13 kilograms. Next one will be the top weight. There's a couple of screws that I missed out by the way in the miscellaneous bag, but as I say, it's only Well, it'll be about 99% correct. So I'm going to weigh this on its own now. That's the top one that sits on the top of the outer drum. If I remember correctly, I think I weighed these on the episode where I took the machine, decommissioning the machine, because I had to take the front panel off and I wanted to make the machine lighter when I was moving it out of the kitchen, and I think I remember weighing them at that time. But anyway, weighing it again, comes in at 10 kilograms. 10 kilograms for the top concrete weight. So top concrete weight, 10 kilograms. Now, just remembered for the miscellaneous bag I've put C video because there's a lot of stuff in that miscellaneous bag. So that's for my reference when I reference back to it. Now I think this is the last one. Thank goodness, this took quite a while actually. I'm going to weigh the drive motor. This is the main primary mover in the washing machine. It's universal. And I'll put them on the scales and get its weight. I remember this one, I weighed them before. But yeah, it's 6 kilograms. I kind of thought it would have been, but I just wanted to weigh it again for this video. So main drive motor comes in at 6 kilograms. So main drive motor, 6 kilograms. Right, now that I've done that task, I could nip away to the toilet now. Because if I went to the toilet during this exercise, it would affect the weight, because liquids weigh quite a bit. So the first drive motor power to weight ratio, 6 kilograms for the output of the power. It's a 660 watt motor, if I remember correctly. But that would be used in terms of if it was in a vehicle, you know, because if it's propelling a vehicle, then it's power to weight. But for a washing machine, it's a static device. It doesn't move, it's just the drum it moves. The weight of the motor doesn't really matter too much. The permanent magnet motor, which is on the rotor in my new washing machine, is considerably smaller. It only has 3 wires going into it as well. Now I need to go to the toilet in person here. One point I'll do, that I'll say before I nip to the bog, is just as a tip, if you're using a table like this, put all the heavy stuff above the legs. Don't put it in the centre, it'll just snap right through. This table doesn't have the centre support, so in case you're wondering, all this goes above the support. There's a wee tip, otherwise you might find the whole thing will just snap in the centre, and you don't want that. Right, I feel a lot better now. So next thing I'm going to do is tally up all the weights and get the overall weight of the washing machine. There you have it, you saw everything that went into making the washing machine, and it tallies up to 74 kilograms approximately. Bear in mind there will be like lime scale in the inner, you know, all that shit. It's on the back of the casting there. That'll add weight as well. I mean, not very much, it'll be negligible, but it's still weight. I mean, if you want to get to the exact gram an ounce, then all that would need to be taken into consideration. Then you've got powder deposits, you know, but then on the other hand, when things are sheared off and wearing, because this machine was scrapped, I scrapped it because of, I showed in an earlier video, I scrapped this machine because of this. Now it's worse on the other side, so I've manoeuvred it around. That's the reason I scrapped it, because eventually that suspension spring was just going to go right through that. The whole drum would have collapsed during usage, and it basically would have been a disaster. If this could have flooded, cause all sorts of damage inside the machine, might even cause a short circuit, and that could cause all sorts of electrical problems within the rest of the house. It should trip the meter, of course, but it's not something you want. And if that thing starts to rattle around when it's sheared off, it could damage the surrounding worktops as well. It'd be an absolute nightmare and disaster, so I wasn't going to wait until that happened. I saw it happening as I was making a video actually, when I was showing this machine working with the top and bottom covers off. You can look back on my video if you want to see that, back on my channel if you want to see that. It's not in the series, but it's quite a bit further back. It was a few months ago. But that's the reason I scrapped it. And that's material as well that would have worn through. It just basically wore through just through the about 10 years of heavy use, and that would have been the end of it, you know. So I caught it in time. I like to say all that gunk down there, all that shit builds up over the years of use, that also adds to weight. So, but then that would be, some of it would be lost due to material wastage through wear and tear, friction in the bearings, all sorts of that's microscopic wear. So I mean, if you want to get it to that accuracy, you'd have to take that into consideration. I can't do that with the equipment I've got. I've only got a set of bathroom scales. I wouldn't be able to capture all the dust and everything, you know. And this has been angle grind in half. All the powder went everywhere, made a right mess, and you'd have to capture all that and weight as well. So it's only going to be about 99%. So it's coming in at 74 kilograms for the gross weight, the overall weight of the washing machine. And through wear and tear and usage, you probably lose the odd washer and things as well. That could also affect weight. You know, when you get the odd screw that'll be missing, connector or clip or cable tie, all that sort of things. It's just, you know, it depends on how accurate you want it. Anyway, I've got the weight and satisfied. I wanted to do that. I wanted to get a breakdown of all the components. I'll look back in this video. I want to know all things. I weighed them on the scales for the kitchen ones for the smaller components, but I just wanted to do it this way with the larger stuff, and now I've done it. So I think that's it. This machine will be going to the skip. I'll maybe salvage and keep a few of the, like the motor could be useful. I haven't broke into that one. It's quite hard anyway, but I might keep hold of it because it could be reused. The pump, I could keep hold of that because it's useful. The ones that are working, by the way. I've got some pumps that were knackered. It was replaced on it, which, by the way, I've done videos on earlier on my channel if you want to see that on this machine when it was in use. What else? So it's just storing stuff. I mean, I haven't got the space to store everything, so just ultimately it has to go in the skip. I mean, I think they've designed these things and build them so that you know the one-time use. It's not like before where you could actually get into things easier. I think they tend to seal things for life so that you, when it comes to replacing, you just replace the whole washing machine. You know, it's quite a lot cheaper and easier to do that. It's a shame I get sentimentally attached to things like that. I mean, I like to keep hold of things for as long as they work. I'd like to replace parts, you know, if that bit where the spring had worn through, if that bit where the mountain for the spring goes through, if that came off as a component and it was made of something substantially stronger, then it could have lasted longer, that washing machine. But then it was never really designed and built for that, in my opinion. Like, for example, getting that drum bearing out, I don't think you could change the rear drum bearings because to get the inner drum out of that outer drum, I had to get an angle grinder and I had to arrange to get it cut in half. So that was done, and then there's no other way to get into it. Like some washing machines you can split the drum, but that one was sealed for life, it would seem. The heating element, that was another nightmare. I couldn't even get that out, it's still in there now. So the things that we did replace on it was the pump. The brushes were needing done on the drive motor, the serviceable parts. Everything else should really last a while. But we used that machine considerably. It was a very heavily used machine, more than average. So it's served us well for about 10 years, so it's pretty good for us. So that's it. Most of this stuff will just end up in the skip. The weights, I'm not going to need them, they'll just go as well. I mean, I could maybe, I don't know, keep hold of them for a bit. The motor I'll definitely be keeping hold of because that in itself could be useful. It's still intact, it was still working, there's no reason to break into that and damage that. That's quite useful, so I could probably find space to store that. But everything else, I mean, I've heard of things like this could be used as a fire pit, you know, all that kind of thing, you know, because it draws in the air from the bottom, flames and burns stuff in it. I don't have a yard or anything to do that. You need a yard for that kind of thing, a backyard. I wouldn't really be interested in doing that anyway. I don't have the space to do it, you know. I mean, I know someone that's got a backyard, but I don't think they'd be interested in doing that. I could run it past them, but well, I don't know, reserve thought on that at the moment, but there's nothing I could do with this. I mean, what do you do with this, like, you know, what can I do with it other than just chuck it out? I don't like throwing things out, but, you know, it comes to a point, the space is valuable. I mean, I don't have any space to store it, so I'm afraid it's considerably lighter now, so I could transport it to the skip much easier. When we got the new washing machine delivered, there was a charge where they could actually install it and take away our old washing machine. Well, we didn't do neither of them, we just got them to deliver it. We installed it ourselves, and I kept the old machine, and I could get rid of it, you know, quite easily now because it's in bits. Lifting it as a unit, because of the shape, makes it extremely difficult. Very awkward, very awkward. So, but now that it's in pieces, it's so much easier to move, and I could just put all that into the back of the car and take it down to the local skip quite easily. Without breaking my back lifting the washing machines. I've done enough of that over the years. It was an absolute nightmare, and then certainly wasn't wanting to be doing that again. So I managed to cure two birds with one cure. took the thing apart so I could get rid of it myself, and I educated myself, because for me it's interesting, and I shared it with yous, and if yous find it interesting as well, then that would be great. I hope you did. I hope you enjoyed this. But this machine, you won't really see any more of it now. That's it. It's going away to the skip, basically. As I say, I'll keep hold of the motor because that can be reused for projects. I don't even know if I could sell it on eBay or something, I don't know, but it's certainly working and it's a useful thing. I don't really want to see that going. The weights, well, I don't know what to do with them. It's just more of interest. So that's it. That's it. I'm going to have to tidy all this junk up. Well, I don't like using that term. It was actually our old machine, and I like it. You know, I don't like thinking of it like that. When I watched its last wash, you know, doing its final wash, it's quite touching because I knew that was it. I mean, prior to that, I never done that with washing machines. I mean, we used to just run the washing machine till it, run it in the ground till it broke completely, and we needed to replace it ASAP. We didn't know it was going to break; it just broke, and that was it. It was usually just too far gone. We tried to fix it as best we could, but we get to that point where we just have to say, right, frustratingly, we just have to get a new machine ASAP because we're stuck. You know, we have to go to the local laundry, and that costs a lot. But with this machine, I knew it was on its last leg, so I was able to actually do a video on it, knowing that this was its final last wash, which I've done on the washing machine series if you want to see it. And as I say, before that, I've done videos on this particular machine with the cover, the top cover off. Then I've done another one with the top and back cover off. And you can see the thing working, you know, the motor turning and the spindle on the belt, shock absorbers working and everything. You get to hear everything going, the pump going, you get to hear the drive motor. I zoomed into the drive motor, you saw the rotor turning, you know, that very machine, and that was interesting. And I think it was one of the videos, I think while I was filming it, I noticed that the suspension bit was worn where it was meeting, you know, that bit there, and I realised that was it. I didn't mention it at the time on the video, I don't think, but I mentioned it later on. I certainly mentioned it to my dad, and then I done a video on that. But that wasn't in this washing machine series, that was prior to that. Right, that's it, okay. Can't think of anything else. I'll just have to round off the video. Right, so that's it. That'll be the end of that. Any other future washing machine series will be done with the new machine, our new one, or any other washing machine that I could title that washing machine series. You know, if there's something interesting I want to make it in, you know, make a video of, I'll just put it in the washing machine series episode. Right, okay. See you later. See you later then. Bye. I'll be keeping that, by the way, just thought I'd mention that. Forgot to mention and keeping the pump. Might even do future experiments with it. Okay, right, well, see you later.